Okay, the question is find the currents I1 through I4 and the voltage V0 in the circuit of figure 3.42. Okay, we are asked to find out what is I1 until I4 and then V0. What is V0? V0 is the voltage here. So let's name that nodes here as node V0. So this is all of this from the here until that here is all P0 here. Okay, and this is our reference node. So we will have this one here. This symbol is our reference node. Reference node, or some people say it that this is the ground node. And what does that mean? That means that the voltage here, V, is equal to 0, right? Because this is the reference node. So this one will be 0, right? And the first step to do nodal analysis is to, one, label the nodes. And then the second one, the second step is to what? Assume the direction of the currents. Assume the currents direction. But we already given that I1 is going down, I2 is going down, I3 is going down, and I4 is going down. And we have these two branches left, but that is a current source branch, so I just follow the arrow of the current source. So this one is going down and this one is going up, right? And then what else that we can do? We can do KCL, the Kirchhoff current law. Do KCL for each nodes. For each node. However, in this case here, we only have one node here, which is V0. So we only need to do KCL at V0. So we will have to do KCL at node 0. Let's do KCL for node 0, P0. What does KCL say? KCL says that the sum of the current that goes in is equal to the sum of the currents that goes out, right? And let's see what the current goes into the node P0 here. The only current that goes in is this 8 ampere. So let's write that. So we'll have 8 ampere as the current that goes in. And that is only one current that goes in. All the other currents, I1, I2, I3, this 20 ampere, and then I4 are going out. So we will have this one here is equal sign. Now let's see, I1 plus I2 plus I3, and then plus 20 here, and then plus I4. Good. Now maybe let's subtract 20 for each side. So we will have minus 12 on the left hand side, and then we will have I1 plus I2 plus I3, and then plus I4. Okay, but I1 until I4 is unknown, so we need to find that out using Ohm's law, right? What is I1? I1 is V0 here. The current comes from V0 and the current goes to the reference node. So we will need to write it as V0. V0 is the node where the current comes from, and then minus 0 where the current goes to. It goes to the reference node divided by 10, like that. And then what else? We can do the same thing for I2. The current comes from P0, so we'll have P0, and the current goes to the reference node, so we'll have minus 0. So we'll have 20 here. And again, we can do the same for I3. So we'll have P0 minus 0 divided by 30. And finally, we will have this one here, V0 minus 0 divided by 60. Right? Okay, all V0 minus 0 is just V0. So we will have minus 12 is equal to V0 over 10 plus V0 over 20 plus V0 over 30 and then plus V0 over 60. Good. Now we can multiply both sides by 60. Why? Because all the denominator here, 10, 20, 30, and 60 will cancel into this 60. So we will have minus 12 multiplied by 60. That will be minus 720. And this one will be 6 V0 plus 3 V0 and then plus 2 V0 and then plus V0, right? And this one will be 9 plus 2, 11, 11 plus 1. So we'll have minus 720 is equal to 12 V0, right? And so we can divide 12 to both sides. So we will have minus 60. Minus 60, and the unit here will be 4. And this is one of the variables that asked by the problem, right? Because we will have V0 here. Okay, what's next? We need to find out I1 through I4. So that is the last step that we need to do for this problem. Answer the question. Okay, but our slide is full. Maybe let's erase this thing first. Okay, so we have P0 here, but from there we can calculate I1 through I4. Let's see what is I1 here. I1 is equal to where the current came from. It came from V0. Then minus where the current goes to, it goes here. So we'll have V0 minus 0 divided by the resistance between them, which is 10. Okay, so we know that V0 is minus 60. Let's plug that in. So we will have minus 60 over 10. And therefore, I1 is equal to minus 6 ampere. Good. Put this into a box, and that is the value of I1. Okay, now do the same game for I2, I3, and I4. So I2 is V0 minus 0 divided by 20. And so we will have minus 60 minus 0 divided by 20, or that will equal to minus 60 divided by 20. Therefore, I2 will be equal to minus 3 ampere. Good. Okay, now let's do I3. It starts to get boring from here. V0 minus 0 divided by 30. And so we'll have minus 60 minus 0 divided by 30. So we will have minus 60 divided by 20. Therefore, I3 is equal to minus 3 ampere. Good. And then what else? We also have this game for I4. So we'll have V0 minus 0 divided by 60. So we'll have minus 60 minus 0 divided by minus 60. No, not minus 60. Don't make any mistakes in the last part. So we'll have minus 60 divided by 60. Therefore, I4 is equal to minus 1 ampere. And I think we have answered all the question because we know all the currents I1 through I4 and also V0, right? This one, this one, this one, this one, and this one. Thank you for watching and see you in the next video. Bye bye.